right, while we're waiting for everybody to get in, and we're almost all here, go to Canvas. Wow. Yeah, the rain can do funny things, funny things. That's all right. I see you in, Piper, so we're good. Be like that some days. Okay. Um, I think we're only waiting for maybe two more people, but I'll go ahead and get started. Here comes one, so I'll wait a minute. Okay, let's share. All right, as long as you can, it's okay that you can't see anyone. Just as long as you can hear what's going on the lesson. That's all that you need to know today. Okay, thank you, Malika. I'll check on that. Okay, today. Um, so the last thing that you all were working on, and not everybody has turned that in, so I want to make sure everybody is up on that because we're doing another activity today that kind of extends from that. So let's kind of revisit what you were supposed to do because you need to do it again today. So we're in Canvas and we're doing protein synthesis. And what you were doing was translating oh, there you are, Piper. Camera's working now. Alrighty. Okay, so there are two things that go on. In the nucleus, we have the DNA. It opens up and it creates a messenger RNA template. And the messenger RNA template leaves the nucleus because the DNA never leaves the nucleus. And it comes out into the cytoplasm, goes to the ribosome. In the ribosome, we set up a template. Actually, I have a short video we can watch to kind of, give me 1 second. It kind of shows you what we're doing. And I do have this in the playlist. Uh, give me, I know that said forensics, but that's just the fastest way for me to get to my YouTube. So bear with me a minute. Okay, stop, because I'm not want. It's not the one we want. Don't play. Um, when you want it to work, it don't work. Okay, go to your channel. Here we go. Let's be the fastest way to find this. Do it this way. Maybe it's- think I added it to your playlist, but we'll see. Okay, there it is. And I think it's on your playlist too, but I know it was on the other classes playlist. So why is it not doing? I may have to stop and share again because it didn't switch to the video. Give me one second.
Stop asking research questions to ChatGPT.
Oh.
Its answers are not reliable, and they are
slow.
difficult to be fact-checked.
It's
just not meant for But Liner is different. Unlike ChatGPT, Liner can be your reliable research assistant. It gives you answers with credible sources, such as academic papers.
Okay, so this is going to give a quick recap of how RNA is.
Translation.
Okay, let me pause it for a minute to make sure that it is sharing. We got one more person coming in, so good timing. All right, so this is just a quick review of what to translation going to transcription going to translation. Remember, so the transcribing in the nucleus, translating in the ribosome. So this will give you a quick overview of that. And then we'll go back and look at the other day's activity as well as today's activity. Come on. Now it's frozen.
Inside the body, the process of translation occurs. Within every single cell, each cell has a nucleus. After transcription, mRNAs move out of the nucleus and enter the cytoplasm. This mRNA
It is buffering
strand acts
badly.
as a template for protein synthesis. Present in the cytoplasm is an enzyme, aminoacyl tRNA synthetase. The enzyme macromolecule has two binding sites. One site recognizes the amino acid methionine.
Uh-oh. Mine is buffering. So it's coming. But there's a part of this I do want you to see at the end so that you kind of understand exactly what it is doing.
This is followed by binding of the ATP molecule and release of pyrophosphate, resulting in activation of amino acid. Finally, tRNA and the activated amino acid bind together. This amino-acylated tRNA is known as met-tRNA and is released from the enzyme. This marks the commencement of the first stage of protein synthesis, the initiation stage. During the initiation stage, a small subunit of ribosome binds to the mRNA strand. The mRNA strand is made up of codons, which are sequences of 3 bases. Then the ribosome subunit moves along the mRNA in 5' to 3' direction until it recognizes the AUG codon or the initiation codon. At this point, met-tRNA, possessing the anticodon UAC, pairs up with the AUG codon of the mRNA. Then a large subunit of ribosome combines with a small ribosomal subunit. The large subunit shows 3 sites: the aceptor site or the A site, the peptidyl site or the P site, the exit site or the E site. This whole unit forms the initiation complex. This is followed by the elongation stage. During this stage, another tRNA carrying molecule of an amino acid approaches the mRNA ribosome complex and fits in the A site. Then a bond is formed between methionine and the amino acid molecule on the tRNA. As a result, met-tRNA becomes deacylated. The ribosome then advances a distance of 1 codon and the deacylated tRNA shifts to the E site from where it dissociates. Meanwhile, another tRNA carrying amino acid molecule attaches to the A site. This is followed by the binding of the amino acid molecules. Repetition of this process leads to the formation of an amino acid chain. This event is called elongation. Finally, when the UAG codon or the stop codon reaches the A site, elongation is terminated. Termination is the last stage of protein synthesis. The chain of amino acid molecules is released from the ribosome. This released amino acid chain is the protein, and this part of protein synthesis is known as translation. Then the tRNA detaches from the mRNA. Ribosome detaches and dissociates into its small and large subunits. Summary. Protein synthesis shows that the first stage involves the binding of the met tRNA to mRNA and the small subunit of the ribosome. The larger subunit of ribosome then combines with the small subunit. The second stage is the elongation stage. In this stage, the incoming amino acyl tRNA fits in the A site. Then a bond is formed between methionine and the amino acid molecule on the tRNA. The process is repeated until a chain of amino acid molecules is formed.
Okay, I'm going to pause it here right now because this is the part I want you to fully understand, is that notice that the tRNAs always go out and they bring in, each tRNA has a triplet code on it that matches one amino acid. It brings that amino acid to the ribosome and then it leaves. So after it's brought its amino acid and the two amino acids connect in the chain, so notice it's forming a chain, then that transfer RNA, which still has the code, goes off and gets another one, another amino acid, and brings it back if necessary. Also, note that it started with methionine, which you need to know is the start codon. And then it will continue until we get to a stop codon. So it'll keep making this chain of amino acids. It'll keep bringing in transfer RNA. Notice like on this conveyor belt, it keeps reading the triplet code, and the triplet code will trigger the transfer RNA to bring another amino acid. And it will keep doing this until we get to the stop codon. Okay, so that was one of the things on your worksheet that you had to recognize.
The last
let it finish.
Stage of protein synthesis is the termination stage. When the ribosome reaches the stop codon UAG, elongation stops and the newly formed amino acid chain, which is the protein macromolecule, detaches from the ribosome. Subsequently, ribosomal subunits, along with the tRNA, dissociate from the mRNA.
Okay, so like I said, this video is in your playlist, so you can watch it again. This was just a nicer illustration of the conversation that you had in Canvas. Canvas went through all of those stages, except it didn't give you a nice picture like that one. So I figured that one illustrated very nicely and gave you the visual of what the triplet codon looks like, how the assembly line actually works, and how the transfer RNA goes and comes and goes, does its job, and then goes away. All right, so you were supposed, so we're going to look at this wheel again, these two things again. So the activity, like I said, only about 3 of you had to submit it, so hopefully you'll get that one done first to get that turned in. But here in questions 3 and 4, you needed to recognize which one was the start codon and which one was the stop codon. So what you had to do was look up here, and the yellow is coded for start, and there's 3 different ways, 3 different codons for stop. All right, if you were filling this out, you needed to have written all of the ways that you could have these guys over here. The all the different codons, because some of these have 2 and 3 codons that will code for the same amino acid. So you need to make sure you do that. With this one, it's important that you take your time and first create the RNA strand and then look at the letters that are created by the RNA strand to figure out what amino acid is that transfer RNA going to go and get, and then put the amino acids down here. So you had 3 pages, 3 lines of that. All right, that was last class assignment. What you need to do today is very similar. So if we're in the module, we're going to look at mutations. So hopefully you had a chance to look at that. If you haven't, you should look at that before you start the next worksheet. All right, so again, mutations. So on the page for mutations, we have the same wheels that you have on your worksheet. And again, you could use the wheel or you can use the chart. Both of them will lead you to the same place, except with the wheel, you start in the middle. And instead of having 3 sides where you go around the chart, you start in the middle and you have 3 circles. You have an inner circle, a second circle, and a third circle. And by the time you get to the third circle, it takes you actually to the 4th circle, which will tell you the name of the amino acid that you're looking for. So, and either one of these will, whichever one you like best is you can use. Like I said, I like the box one because it's a little more straightforward, but you can use either one. They're going to give you this amino acid. Now, what this particular one in Canvas is doing, it gives you, instead of just on giving you the 3-letter abbreviation, it also spells out the whole name of the amino acid for you. So you can get familiar with the full name of the amino acid by looking at the wheels in Canvas. Alrighty, so we're making our protein, and the messenger RNA tells you exactly which amino acid to go and get. But if, for example, and then a couple of you that I've already looked at, you coded it wrong. So if you read the code wrong, whatever that code is, that's the transfer RNA that's going to come back with another amino acid. But if that amino acid is not supposed to be part of that sequence, then it creates a protein that is not designed to do the job that you want it to do. So we call that a mutation. Let's look at that for a minute. You gotta read this one, it doesn't talk. Actually, let me pause it right there. Whoops, didn't pause it fast enough. Okay, so mutation is a random change in the DNA sequence. So it could have started in the nucleus where the RNA read the DNA wrong, or it could happen in the ribosome where it brings the wrong amino acid in place. But in any case, there is a sequence of amino acids that are not the kind that you wanted for that particular protein. So one example of such a disease that has a wrong sequence of amino acids is sickle cell anemia. So the activity that you're going to do today is going to be looking at the sequence that happens with sickle cell anemia. So I'm going to let this finish. Actually, this is very fast. All right, so most are minor, some are lethal. Like in the case of sickle cell, it can be harmful. Every once in a while, it doesn't matter. It says very few are helpful. Okay. All right.
Using Powtoon.
Okay. So what I want you to do is, yours might be in the module. Give me 1 second. Maybe not. No, it's not. All right, go to your home page. And you want to click on DNA protein mutations. It should be on your home page under things to do. All right, when you click on it, you should get a worksheet that looks like sometime today. Hopefully yours isn't taking as long as mine. All right. So one of the other things that you need to remember is after that chain of amino acids forms, it doesn't stay a long chain like a string of beads. It curls up. Okay. So it creates this coiled structure. And that's what the N protein molecule will look like. All right. What we're going to look at today is sickle cell and how it forms an abnormal shape of the blood. It's locked until the 20th. Okay, let me fix that today. Oh, it should have been the other way around. It should be opened today. And okay, give me 1 second to fix that. Okay, it should be available. Today's the 19th. And then it can stay. Okay, the other date can stay. All right, so wait a second. Okay, all right. Refresh your page and it should be available now. View as a student. Guess if I viewed it as a student, I would have known that. Okay, so again, refresh your page. It should be open now. So thank you, Malik and Zella, for telling me that. Okay. So again, you're going to do a similar thing that you do with the other worksheets. You're going to do first a normal, okay, let me backtrack. Sickle cell, the protein for sickle cell, for the normal protein that's supposed to be created, helps you create a red blood cell that is nice and round with that nice donut shaped dip in the middle. That's what your red blood cell is supposed to look like. All right. So it's designed to make hemoglobin. So that hemoglobin protein gives you a nice shape to your red blood cell. What happens with the sickle cell protein, it alters the shape. With the function of the red blood cell is to carry oxygen. The nice round shape that it has allows it to carry the maximum amount of oxygen. With sickle cell, it alters the shape of the protein. So it still makes a red blood cell, but now it's sickle shape, kind of a curved shape to it. And it does not hold as much oxygen as a regular red blood cell should. So consequently, some of the side effects of sickle cell anemia is they're always, sometimes they need to be on an oxygen tank because they're not getting enough oxygen because their cells are not carrying the amount of oxygen that it should because of the mutation. All right, so what you're going to do is you're going to create a regular strand. You're going to get the normal set of amino acids, and then you're going to look at what happens. And I want you to take note of which amino acid, which defect is showing up on this DNA strand, which is going to code for a wrong amino acid. So take note of that. All right, once you've done that, you have this part down here with the picture. So you have normal cells and you have a sickle cell, and then you answer those questions. And here again, you have another chart that you can use on the worksheet. Or if you want to have them side by side, you can have Canvas open and use the one on Canvas. But like I said, they're all the same. So you're going to have to use the chart to help you fill in the blanks. Okay, everybody able to download the worksheet now? All right, so you're doing a normal code and making a normal strand of protein. Then you're going to do a mutated code to make the strand that will code for sickle cell anemia. And then you're going to answer the questions. And then you're going to send it back to me. All right, so between the last one and this one, I think you'll be able to finish both of these today. Okay, any questions? Questions? All right, I don't know what happened to Landon. He was in, but now he's gone. All right, so I'm going to stop sharing so that I can do attendance. All right, again, if you have trouble getting the worksheet down, let me know. Everybody should be working on the worksheet. It is due today. being as this is the week before Thanksgiving, we want to make sure that we get all assignments in before Friday. So again, try to make sure that this is done today. It actually, the due date now is tomorrow. So we got something else to do tomorrow. So make sure you're not still doing this. We want to make sure this unit is finished this week. And when you come back from Thanksgiving, we start the new unit. I don't know where Landon went. Okay, Malik, give me 1 second. I took care of that other one for you. Give me 1 second to pull up the question. Um, Oh, my goodness. Okay, question 3 on today's assignment, Malik. All right, for question 3, you have to fill in the blanks. You want to use vocabulary, so Canvas may help you with this discussion. There is no word bank, but you need to be able to explain uh, what what a DNA molecule is. So now these letters are not, excuse me, they're not multiple choice. They are there to give you a hint as to what do you call these 4 things. So that's the answer that should go on that first blank. And then you need to be able to describe what is happening to the DNA molecule during transcription, and then what travels to the cytoplasm, and so on and so forth. So you need to be able to explain, fill in the blank with words that complete the story as to the process of translation and transcription. And again, Canvas can help you with this. Okay. Malik, did I answer your question? Is that the number 3 that you wanted to know? Okay, good. All right, so yes, this is fill in the blank, and yes, that first one is not multiple choice. They want, what do you call these things? There are 4 somethings. Okay, and then fill in the blanks with the remaining answers. Again, folks, if you have a problem, ask. All right, I lost Ariana. Where'd you go? Yes, yes, Malik. They actually have a longer name than that, but yes. Mm. All right, gotcha. All right, thank you, Malik. All right, some of you haven't submitted the first one, so please make sure you submit the first one. And I got a couple of you who have submitted today. Thank you. If you finish today, just go ahead and read let me see and make sure that I have published it. I think you, so please make sure you have turned in the first one, Natalie, before you turn in the second. Like I see you have the second one, but you didn't turn in the first one. So make sure you do that. Let me make sure your modules are published. So again, please read mutations. We are going to try to, oops. Okay, let me publish the next one. There was an activity on that page for mutations that you need to make sure that you try to do. DNA technology is the next unit. Some of that went along with our little Halloween activity that we need to talk about the latest technology in studying DNA. So that's what we will do next class, is focus on what to do and how to do it. Okay, this activity was in your module. It just needed to be, it's at the end of the module, but it is in your module. Let me see if I can move it. Okay, just a reminder too that when you submit, I would rather you submit a late assignment than have a zero. So you should do that, but the Canvas is going to take a quarter of a point off for each day that it's late. So if you let it get late too far late, it almost amounts to not doing the assignment. So if you're going to do it, get full credit. Oh, and by the way, on that first worksheet, the amino acid really was, I said GIN, G-I-N, but it really is G-L-N because the correct name for that amino acid is glutamine. So it's not G-I-N. I know it kind of looks like that on the chart, but it's G-L-N for glutamine.
As I'm in the midst of applying for residency.
Thanks. Action. Okay. Anybody have any questions? Everybody turned in their work. Remember yesterday's last class assignment was due today. Next one is due tomorrow. If you have no questions for me, you all have a great rest of your day.